Alright, so today we are going to find the standard deviation of the quiz scores of a class of 6 students. So the quiz scores are given to us as 22%, 54%, 77%, 89%, 100%, and 99%. So before we can start, we need to know what standard deviation is. So standard deviation is defined as basically the deviation of the values from the mean. So we got let's say we got the mean right here. This is mu. This stands for the mean. Mean is how much, standard deviation is how much the values are going to deviate away from the mean. So this is a population parameter. This is mean. This will be for a sample. It's going to be x bar. This is for a sample. This is the mean of a sample, and this is the mean of a population. They're pretty much the same thing. It's just this one belongs to a sample, and this is called mu. It belongs to a population. So in this case, since we're looking at the population of the class, which is 6 students, we are going to use the population standard deviation formula. Not the sample standard deviation formula, but the population one. So it's gonna go like this. That sigma is equal to the sum of x minus mu squared divided by n, and you square root the entire thing. Sorry if it looks like that. I'm filming with one hand. So that's going to be your population standard deviation formula. Sigma equals the sum, that little thing that looks like an E is sum of x minus the mu squared divided by n. So we need to break this up. N is going to equal your population size. So n is your population size. N is equal population size. That's an n, by the way. So n is equal to your population size. What is our population size? It says a class of 6 students. So our population size is going to be 6. So n is equal to 6 because we have 6 students in the class. So what is going to be your x value? Your x value is going to be pretty much all of these: 22%, 54%, 77%, all the way to 100%, 99%. So that's going to be your x. That's going to go inside your x value, and I'll show you how to do that in a minute. So sorry about this focus. I'm deeply sorry. Mu. What is going to be mu? Remember what I said, that mu, since this is a population standard deviation, we're looking at mu. That's our population, mu, and that's our sample, x bar. We're going to look at mu. Mu is going to be the mean. So mu is going to be the mean. So the mean is basically adding all of these numbers and dividing by the pretty much amount of numbers. So let's say we have six numbers here, 22% all the way to 99%. We got 6 of them. We're going to add them all together, and we're going to divide by 6 to get our mu, our mean. So we have, let me just write them all down. We got 22 plus 54 plus 77 plus 89 plus 100 plus 99. So all of these numbers are going to get together and be divided by 6. So let's do that right now. Let's get our calculator and do that right now. All right. 22 plus 54 plus 77 plus 89 plus 100 plus 99 gives us 441. Now we have to divide that 441 divided by 6. since that is the amount of values that we have in our population. So 6. That's going to give us to 73.5. So that's going to be our mean. That's going to be mu. So ignore this. Mu is equal to 73.5. Sorry about that. Whatever, 73.5. That's mu, 73.5. Mean is equal to 73.5. And now we can start solving for the equation. We can start constructing our table. So in our first column of the table, we're going to have our x values. So that's going to be x. Draw a line. So for our x values, we are going to plug in basically all of these numbers, 22, 54, 77, 89, 100, and 99. We're going to plug them in to this table. So that is going to give us our first column of the table. These are going to be all of your x values. 22, 54, 77, 89, 100, 99. It's going to look like that. Draw your line to separate. It's going to look like that. So what is our equation asking us? Our equation is asking us to subtract the mu from the x value and then square it. And then we're going to take the sum of all of those x to take away, like all those x subtracted by the mu. We're going to and square. We're going to take the sum of it and divide it by n, and then at the end we're going to square root it by, well, we're just going to square root it. So first things first, we have our x values, and now we need to subtract mean from all of our x values. So mu, this is going to be our mu. If you recall, our mu is 73.5, the value that we found earlier. So 73.5. 73.5. So what you want to do now is subtract 73.5 from all of these numbers. So 22, take away 73.5, 54, take away 73.5, 77, take away 73.5, and so on. Like that. So now that's going to give us our third column. The x value minus mu. So now we're going to head and subtract every single x value from 73.5. All of them. And we're going to put our answers in this column. So let's do that right now. Take out the calculator. Our first value is 22 minus the mean, mu, 73.5. 73.5. That's going to give us to a negative 51.5. So we're going to write that down, negative 51.5. Our other x value, 54. 54 minus mu of 73.5. 54 minus 73.5. Negative 19.5. Negative 19.5. Now our other value, 77. 77 minus 73.5. 73.5. 3.5. So you're going to do that for all of the values, and then we'll check and see what we got. So for all values. All right, so you should have gotten 15.5, 26.5, and 25.5 for the rest of the values. So this is our third column, x minus mu of 73.5. Now, since this is our third column, we're going to have to separate it. Now our fourth column, that is going to be, since our equation is asking us for the sum of x minus the mu squared we're going to do x minus the mu squared. So this is what our fourth column is going to look like. X minus mu squared. So what does that mean? That means we're going to take the values that we got right here under the x minus mu, under that column, we're going to take all of these values. So each one of the value, we're going to square them. So 51.5 squared, we're going to write right here for every single one of them. So let's go ahead and do that right now. So 51.5 negative, sorry about that, negative 51.5. Negative 51.5 times negative 51.5. That is going to give us 2,652.25. 2,652.25. I also forgot to mention that standard deviation, like after doing the entire calculation, standard deviation cannot be negative. So standard deviation cannot be negative. If you got a negative number, and it's not correct. So just keep that in mind, that standard deviation sigma cannot be negative. So let's go ahead and do the second value, negative 19.5. Negative 19.5 times negative 19.5. That's going to give us 380.25. 380.25. The other value, 3.5. 3.5 times 3.5. That's going to give us 12.25. So 12.25. Keep doing that for all of the values that you see here, kind of just like I did right here. Keep doing that, and we'll see what we got. All right, so this is what I got. 12.25, 240.25, 70. That's a 2, by the way. Sorry about that. 702.25, and then 650.25. So that's what you should have gotten for our column of x minus the mu squared. So what does the equation want us to do? The sum, that little thing that looks like an e, is a sum. So it wants the sum of x minus mu squared. So it wants the sum of all of these values. So we're going to go ahead and do that right now. So what we should be doing is we should be getting the sum of all those values. So basically just add all of these together. 2,652.25 plus 380.25 plus 12.25 plus 240.25 plus 702.25 plus 650.25. So we're going to add all of them together. So I'm going to go ahead and do that right now, and I'm going to show you what I got. So you put that into your calculator and you get 4,637.5. 4,637.5. 4,637.5 should be the sum of all of these, just this column, all of these values, all of those. Not all of these, but all of those. 4,637.5. So, what now? You are going to, basically we're pretty much good to do our equation. So our equation is sigma equals the sum of x minus the mu squared. We have that right here. 4,637.5. 4,637.5. 4,637.5. Our n, remember our n is going to be our population size. What is our population size? Remember, our population size is a class of 6 students, so our population is 6. We are talking about the population because this is not a sample. These are the results of all of the 6 students in the class. A sample would be like, let's say, only 2 of these. But this is a population. Population because there's only 6 students in this class. So n is going to equal to 6. 6. Obviously, you're going to square root that, but we're going to save that till later because I want to show you something. So let's go ahead and do that. So 4,637.5 divided by 6. That is going to give us 772.91. For now, let's round to 2 decimal places. So that is going to give us sigma is equal to 772.92. But don't go just yet. We're not done just yet. This is going to equal our variance. Variance is denoted by sigma squared. So this is going to be our variance. The problem does not ask you to find variance, but if it were to ask you to find variance, this will be your variance. Your variance formula is sigma squared equals the sum of x minus mu squared over n. That is your equation for the population variance. This is for the population variance, not the sample variance, but population variance. Look at the difference between the population variance and the population standard deviation equation. They're basically the same, except this one is square rooted and this one is not. This one has this one's raised to the power of 2. This one is not. That is how you can tell the difference between the variance, population standard deviation. We have our population variance right now because we haven't square rooted. But when we do square root it, we are going to get our population standard deviation. So let's do that right now. Sigma equals to, we're going to take our variance and square root our variance. Our variance is going to be 772.29. 772.92, 92, sorry about that. 92. This is how we're going to find our population standard deviation. We already found our variance. This is our variance. Let's square it. Let's box that. That's our variance. We're going to have to square that to find our population standard deviation. So let's do that right now. Next one. So squared 7772.92. That's going to give us 27.80. Let's just say that. 27.8. So this is going to give us, so sigma is equal to 27.8. 27.8. That is our standard deviation. That is how many values are, that's how many variations, how many standard deviations our value deviates away from the mean. The mean being 73.25. That is how much our values deviate away from the mean. That is your standard deviation. That is your variance. Remember, the population standard deviation, actually all standard deviations cannot be negative. And remember, the population variance and the population standard deviation, they're inverses of each other. This one is you have to square root it to get your population standard deviation. This one you have to square it to get your variance. So if you square this, you're going to get this. If you square root this, you're going to get this. They're inverses of each other. And remember that this, we're looking at a population. We're not looking at a sample. The sample formula for standard deviation for variance and this one, standard deviation, is going to be not a lot different, but it's going to be different. So make sure to pay attention to the question to know that this is a population. Why? Because there's only 6 students in this class. This is the 6 students, and this is their test, their quiz scores for them. This is the population. The population is 6 students. Well, I hope this helped. Thank you, and have a good day.